You know that feeling, right? You give an AI assistant a specific document, you ask it a question, and you just can't shake the suspicion that it's not really using it. Is it pulling from your file, or is it just winging it based on old data? Well, that question of trust is a huge deal in AI, and today we're going to break down some really cool research that teaches AI how to actually show its work. All right, so here's our roadmap. First, we're going to talk about the problem. What happens when an AI just doesn't listen? Then we'll expose the flaw in how we've been training them all along. After that, and this is the exciting part, we'll get into the brand new solution for teaching AI to be confident in the right way. Of course, we'll look at the proof, the hard data, and we'll wrap it all up with why this matters so much. Okay, so imagine you give an AI a detailed report and you ask it a question about page 5. You expect an answer from page 5, right? That's it. In the world of AI, that's called faithfulness. It means the AI sticks to the script you gave it. But as you've probably guessed, they don't always do that. And this, right here, is the absolute core of the issue. If the AI decides to ignore your document, it could spit out an answer that's old, totally wrong, or worse, something it completely made up. You know, what we call a hallucination. We've got to find a way to make sure its answers are actually grounded in the evidence we're handing it. Now, the top-tier tech for this is called Retrieval Augmented Generation, or just RAG. The easiest way to think about it is that we're giving the AI a library card. It can go look things up before it speaks. But there's a huge catch. Sometimes the AI leaves the library books on the shelf and just answers from its parametric memory, all the general knowledge it was trained on. And if that built-in knowledge is out of date, well, you're going to get a bad answer. So why on earth does this happen? If the AI has the right info sitting right in front of it, why would it ignore it? Well, it turns out the problem isn't with the AI's ability to read, it's with how we've been grading its homework. We've been so focused on the final answer, we forgot to check its work. This diagram just nails the problem. Look at that top path. That's the old way. The AI gives 3 different answers to where's the Eiffel Tower. One answer correctly cites the document, one is a pure guess, and one literally says, I'm just going to use my own knowledge. But because the answer, Paris, is correct every time, the external judge gives them all a perfect score. It's like a teacher who gives you an A+ as long as the answer is right, even if you just copied it from your friend. So this is a massive shift in thinking. The goal isn't just about getting the right answer anymore. The new goal is to reward the AI for following the rules, for using the evidence. We have to teach it to show its work, not just to be a good guesser. And this brings us to the really elegant solution behind all this research. It's a brand new framework called CTR-RAG, and its whole purpose is to teach the AI to be confident only when it has a good reason to be. The secret sauce here is a method called Contrastive Likelihood Reward, or CLR. So, forget that external judge. This creates a kind of internal check, where the AI grades its own confidence level. It only gets a reward when its confidence goes up because it used a specific piece of evidence from the documents. And this is how that slick little test actually works. So first, the AI answers the question with all the evidence. Then, and here's the trick, this system finds the single most important document and hides it. Now, the AI has to answer again, but without its cheat sheet. And what the system is looking for is a big drop in confidence. If the AI's confidence plummets, that's a good thing. It means it knew that document was important. And for figuring that out, it gets a huge reward. And hey, don't just take my word for it. The researchers themselves say this whole process trains the model to zero in on the right evidence. It's not just about being right anymore, it's about being right for the right reasons. So the theory is fantastic, right? But does this clever training actually work in the real world? Let's get into the data because the proof is pretty striking. Take a look at this. Those green bars show reference reliance. That's basically a score for how much better the AI gets when it has documents compared to when it doesn't. And you can see, as training goes on, that score just keeps climbing, a solid 6% improvement. But look at the blue line at the bottom. That's the AI's performance with no documents, and it stays completely flat. That is key. It means the AI isn't just memorizing new facts, it's getting better at using the tools it's given. This graph here tells the exact same story, just in a different way. Now, perplexity is just a fancy academic term for confusion. So look at that orange line. When the AI has no documents to help it, its confusion goes up and up. But the blue line, when it has the documents, stays nice and low. This is perfect. It's learning to be uncertain when it's guessing and confident when it has proof. And here's the bottom line, raw accuracy. On really complex tasks, your normal model gets it right about 80% of the time. But the CTR-RAG model, it jumps all the way up to 85%. Now, that might not sound like a lot, but in the AI world, that is a huge leap forward. In fact, if you boil it all down to one number, it's this one. That reference Reliance score we were just talking about ends up at 0.559. That absolutely crushes the score from a standard model, which was down at 0.429. It's just proof positive that the AI is getting much, much better at using its references. So let's step back for a second. What's the big picture here? This isn't just about tweaking an algorithm to get better scores. This is about building a future with AI that we can actually trust. So what we get out of all this is an AI that's just fundamentally more dependable. It's less likely to hallucinate because it's trained to be faithful to the facts. It's a better reasoner, able to connect the dots between sources. And, here's a fun little bonus, it even learns to be more concise and stop rambling. All of this leads to the one thing we really need, an AI we can trust. And that trust changes everything. When you have an AI that can be relied on to stick to the facts, you can start using it for the really big stuff. Things like medical diagnoses, high-stakes financial analysis, or complex scientific research where being wrong just isn't an option. So I'll leave you with this final thought. Once we have AI that can consistently show its work, that can prove how it got an answer, that trust barrier starts to crumble. The question isn't if we can trust AI with our biggest problems anymore. The real question is, what are we going to trust it with first?